Hello everyone, myself Reeba, Assistant Professor from CSE Department, St. Joseph College of Engineering, Chennai. In this lecture, we are going to see the topic Linux system, design principles and its kernel models and mobile OS. In this mobile OS, we are going to see two types, that is one is Android and iOS, so which comes under Unit 5. So first we can see the history of Linux. So Linux is a modern free operating system based on Unix standards. So Linux is a completely free OS and it is based on Unix standards. It was first developed in the year 1991 by Linus Torvalds. And here the main design goal of Linux was its Unix compatibility. And we can see the basic concepts of Linux now. Linux is one of the most popular versions of Unix like operating system. As I told earlier, it is a completely free operating system. And let's see the key features of Linux one by one. First one, it is an open source. So here the source code is freely available and it is free to use. So anyone can use the Linux OS without any licensing cost. And the third feature, it is Unix compatibility. It works similar to the Unix system and it supports multi-user and multitasking, which means multiple user can use the operating system at the same time and multiple processes can run at the same time. Portable, the program can OS can run on many hardware platforms. And next feature is secure and reliable. So it has some strong user permissions and stability. So next we can see the components of Linux system. So Linux operating system mainly consists of three core components. So the first one is kernel. So kernel, it is the core of Linux, or we can call it as the heart of Linux operating system. It directly interacts with the hardware of the system and it manages all the major system operations. So kernel we call the core or heart of Linux OS. It has the direct interaction with the hardware and it is managing the all core components. So this is an example or diagram of Linux OS. This is an architecture of Linux OS, and here this kernel, it is the main or core part of OS, and kernel, it has the direct contact with the hardware, which is CPU, RAM and IO. And here the next component is system libraries. So system libraries, they act as an interface between the applications and the kernel. Okay, and here they provide some predefined functions to access the kernel services. Whenever they want to access any kernel services, so the system libraries will provide some predefined function. And the third component is system utilities. So system utilities are programs that perform specific tasks for users. So system utilities are nothing but they are small programs, and that programs will have some specific tasks for the users. It also provides some user level interaction with the system, and it also performs operations like file management, which has the command like ls. Ls is used for listing the contents of a file, and cp for copying a file, and move, it is purely for moving a directory. Okay, so next operation is disk management. So it manages all the disk. And third one, process monitoring. Here there are two commands. One is top and ps. So top is mainly used for seeing the current live process. Okay, and ps, it is a command used for taking the snap of a currently actively running process. And fourth operation, system configuration. So the system utilities, they helps to perform such specific tasks and they perform operations. The next, we can see two types of mode. There are two types of mode. One is kernel mode, which is called as a privileged mode. And here, kernel mode is a privileged execution mode where the kernel runs. So we know the kernel runs in a kernel mode, and this kernel, it has the full access to the system resources like CPU, memory and hardware devices. So kernel has the only one which has full access to the system resources like hardware devices. So here, let's see the features of kernel, and here it has the direct access to hardware and it execute the core OS functions. So what are the core OS functions? That is, it is scheduling, process management. So all the core functions are executed by this kernel, and it runs in a single address space. And here there is no need for frequent context switching. So what is meant by context switching? So context switching is in the sense the process which is switching from one state to another. In that case, the process should save the state of current process, and then it has to switch on or move on to the next process. Okay, so in this kernel mode there is no need for frequent context switching, so that is, it is much efficient and fast, and it can handle process management, memory management, device drivers. So all the devices are connected through device drivers. So this kernel is handling all the process management, memory management, system drivers and system calls. The next mode is user mode. So we have seen that kernel, it is a privileged mode, and the kernel runs in a kernel mode, and whereas user mode, it is a non-privileged mode. So user mode is where the user applications and the system programs run. So user mode is the place where user applications and system programs run. So it has only limited access to system resources, whereas we have seen that the kernel, it has the full access to system resources, whereas user mode, it has only limited access to the system resources. Let's see the features of user mode. So it cannot directly access the hardware or kernel, and it will run in a separate address space. Okay, and it also uses system libraries to request kernel services. So if it want to access the kernel or kernel services, it has to use some system libraries. Okay, next we can see the architecture of Linux system. The architecture of Linux system consists of the following layers. The first one is hardware layer, second one kernel, third shell, and fourth is utilities. Okay, so this is the architecture of Linux system. So let's see the layer one by one. The first, it is a hardware layer. So the hardware consists of all peripheral devices. So we call the RAM, HDD, CPU all as hardware. So hardware, it consists of all the peripheral devices. Moving to the next, kernel. So kernel, as I told earlier, it is the core or heart of operating system, which has the direct contact with the hardware, and it also provides some low services to the upper components. And the third component, it is shell. So shell is an interface to the kernel. It will hide the complexity of kernel's functions from the user. So the shell is something, it hides the kernel's functions from the user. So the shell takes commands from the user and execute the kernel functions. And fourth layer, it is utilities. So utility programs that provide the user most of the functionalities of the operating system. So most of the functionalities of OS are provided by this utility. Okay, so next, so this is the architecture of Linux system. So here there are three layers, that is, as I told, this is a shell and kernel, hardware. So hardware, so this is everything that this hardware is the place where everything runs, like CPU, your memory and disk. Okay, the next, moving to kernel. So kernel, it interacts with the hardware, so it is having the direct contact with the hardware. So we can call this kernel as the brain of OS, and this. Okay, and next, the third component is shell. Okay, so shell, it acts as an interface between user and the kernel. So shell is an interface between user and the kernel, and it accepts user commands and sends them to the kernel. So what does the shell do? This shell, it accepts the user commands and it will send them to the kernel. Okay, And for example, we can say bash sh command. Okay, so the next one, applications. So applications or utilitars, we call it as. Okay, so this applications or utilitars, so this is the outermost layer, outer layer. So this applications or utilitars, they are the programs the users interact with. So through this system utilitars, the users interact with. And here there are multiple users. We can say this is user 1, user 2, user 3 and user n. Okay, so multiple users use each system and each user will use particular programs. Okay, so each user interacts through the shell and application. So here there are multiple users and these multiple users, they interact through the shell and the applications. Okay, and it contains the user programs and commands. So here there are many commands. Let us see this vi. Vi is used for text editor, and cd, it is the command used for change directory. The next grep, grep, it is mainly used for searching text. Okay, so this is the architecture of Linux. The main core component are kernel, hardware, shell and the applications or utility programs. The next we can see the topic design principles of Linux. So Linux is designed based on efficiency, flexibility and compatibility with Unix standards. So Linux operating system is purely it is designed based on the Unix standards. The main design principles are Linux is a multi-user and multitasking system. Okay, so the Linux, it supports multi-user in the sense many user can use the system at the same time. Also multiple processes can run at the same time. Okay, so next, Linux is Unix compatible. So meaning it follows Unix standards and conventions, making it easy to port Unix applications. So Linux is Unix compatible. So meaning it always follows the standard principles of Unix. Okay, so let us take an example. So where you can a program written for Unix can run on Linux with little or no modification. So you are writing a program. So that program, okay, so you are writing a program for Unix that can run on Linux without modification or little modification. Okay, so that is the meaning. So example, you can say shell scripts written in Unix that works directly on Linux. That is the meaning of Unix compatibility. The next, third, its file system follows traditional Unix semantics. So that is, everything in Linux is treated as a file. Okay, so here everything is treated as a file. Okay, so example, for example, /dev USB, which means your USB device, or dev SDA, it is a hard disk. Okay, so everything is treated as a file. Okay, so you can read or write devices just like files. So you can read or write just like files. So that is the meaning of the file system that follows traditional Unix semantics. The next is Linux fully implements the standard Unix networking model. it supports the protocols like TCP or IP, and it enables the efficient communication in network environments. So here Linux follows a standard way of communication over network. So it follows some network rules. Okay, so for example, when you open a website, so when you are opening a website, say Google or YouTube, your request goes to the Linux server. So the request will go to the Linux server, and that server, it runs on software like Apache. Okay, so whenever you are opening a website like Google or YouTube, the request will be sent to the Linux server, and that server will run the software like Apache. Okay, so that is the meaning of this. The next one, the Linux programming interface, so it is strictly adheres to the SVR4. So SVR4 in the sense System 5 Release 4 Unix semantics. So it ensures standardized system behavior for process, file handling, and IPC. So which means Linux behaves in a standard and predictable way like Unix system. So this Linux, it behaves like Unix system. Okay, so for example, the operations like fork off, ex, easy off. So what is the use of fork off? As we all know, this fork off, it creates a new process. Clear? So it creates a new process, and this exec, it runs a program. So these two works the same way in all Linux systems. So that is the meaning. Okay, so this Linux programming interface, it strictly adheres to the SVR4 system, that is System 5 Release 4 Unix semantics, ensuring standardized system behavior for all process of file handling and IPC. The next, Linux is a POSIX compliant, ensuring portability and compatibility of applications across different systems. Okay, so what is this POSIX? So POSIX in the sense portable operating system interface. Okay, so it ensures that a program can run on different system. So a single program that can run on different system. Okay, so here the Linux will follow some international rules or standard rules for programming. So in simple, I can say that you are writing a program once. Okay, the meaning is write once, it can run anywhere. Okay, so if you are writing a example, if you are writing a C program that is written using POSIX, it can works on Linux as well as Mac OS and Unix. Okay, so it can run on everywhere. Okay, so the meaning is you can write once that runs on different or run on anywhere. Okay. So the next topic is kernel modules. So kernel modules are small pieces of code that can be loaded or removed from the kernel whenever needed. So these modules are nothing, a small piece of code. Whenever they are needed, they are loaded and they are removed from the kernel. So they run in kernel mode. So these modules, they run in kernel mode, which has the full access to hardware. So for loading into the kernel, no need to restart the system. Okay, so consider an example here. Think of your Linux kernel like your mobile. So in this, your phone is the kernel, and the apps you're gonna to install are the kernel modules. So for installing apps like WhatsApp or any apps, you don't want to rebuild your phone or you don't want to restart your phone. You can just install an app. So these are the kernel. So phone is like your kernel and apps are the kernel module. So Linux add features using these modules instead of rebuilding the kernels. Okay. So the next is components of module. So the first is module management system, second module loader and unloader. Okay, so here the module management system, it handles loading modules into the memory and also it allows the communication with the kernel. And the next is module loader. So whenever the modules are needed to load it into kernel, so this module loader will help us to load and unload. Okay, and the next is driver registration system. So this driver registration system, it tells the kernel that a new driver is available. Whenever any driver you want to install this, it will tells the kernel, that is the driver registration system, it will tells the kernel that a new driver is available. Okay, the next is conflict resolution mechanism. It prevents multiple drivers from using the same hardware. So multiple multiple device may use the same hardware. So this conflict resolution mechanism, it will prevent multiple drivers from using the same hardware. For example, you can say this printer driver, a network driver, they all use the same port. The next topic is mobile OS, Android and iOS. Okay, so first we can see what is the definition of mobile OS. So the primary software that allows mobile devices to run application and programs. So this mobile OS, they are the software that allows your mobile devices like phones, tablets or any other wearables to run application programs. Okay, and it acts as a system bridge. Okay, so it acts as a system bridge. So here it acts as an essential link between the user and the hardware. Okay, and also it acts as a manager. It manages all the interaction between the software application and your physical hardware. Okay, and the next is, it is a user interface. Okay, so when a device is turned on, the OS initialize the interface. So whenever your device, your mobile device is turned on, the OS, it will initialize the interface. So visual access, so it typically displays a home screen featuring icons. So whenever your device is turned on, you may see some icons like circles or whatever, maybe it's square or something. So that it will display a home screen featuring icons or squares. So these visual elements provide quick access to the applications and display the real-time information. So whenever you're clicking this icons, okay, it will access to the applications and display your information. And let's see what are the services provided by the operating system. Okay, one by one. Okay, so first one, it is program execution. Here this program execution, it is responsible for executing both user and the system programs. Okay, and next is handling IO operations. So it manages the input from devices like keyboards and mouse and handles data interfacing between various peripheral devices. So manipulation of file system. So this mobile OS, it also makes decision regarding your data storage on hard disk, pen drives, etc. It determines how files are organized, stored and manipulated, how the file system is organized and how it is stored and how the files are manipulated. All are dealt by this OS. Okay, and it also provides services like error detection and handling. So it identifies the errors or bugs during any system task. It also acts as a security countermeasure to prevent and handle some external breaches. The next is, it also acts as a resource allocator. So as you all know, this OS, the main function is the resource allocator. It also ensures proper utilization of all available resources, decides which user or program gets a resource and for how long. So it will decide which program has to allocate, or which program gets a resource and how long a program can use a particular resource. So that all will be decided by the OS. Networking, so it enables communication with other system and devices. And scheduling, so scheduling here, it determines the order of task execution. So here in which order the process has to execute it. So all this, it will be determined by the OS. And the next is IPC. So it also provides services for communication. So IPC, mainly inter-process communication, mainly used for communication among different processes. Okay. So process may communicate for sharing resources. So that services is provided by the OS. And next, performance monitoring. So here resource tracking, so monitors usage of CPU. So the usage of CPU, memory, disk and network, all are monitored by this OS. And also the last is backup and recovery. So here it will safeguard information against system failure, tools to restore data in the event of loss. So it has a backup and a recovery plan for whenever any information is lost. And next, here we can see the architecture of Apple Mac OS and iOS OS. Okay, the first layer is application layer, and second one user experience. Third, it is application framework, and next core framework, and the bottom layer is kernel environment. So in Mac OS and iOS, we call this kernel as Darwin. Okay, so Darwin is the name of the kernel. And here when you see this architecture, here this application layer has direct contact with all the layers. So application is having the direct contact with user experience layer and framework and core framework and also the kernel. Okay. So let's see the architecture layer one by one. So first one, it is user experience layer. So it defines the software interface for user interaction. So here Mac OS, it uses Aqua interface, and iOS, we call it as Springboard interface. Okay, so the interface for Mac OS is Aqua, and for iOS we call it a Springboard interface. Okay, it is specifically designed for touch devices. And the next layer, it is application framework layer. It includes Cocoa for Mac OS, Cocoa Touch for iOS. So for Mac OS, we call that application framework as Cocoa, and for iOS we call it as Cocoa Touch. It provides API. API means application programmable interface for Objective-C and Swift. This Cocoa Touch specifically supports hardware unique to mobile devices like touch screen. The next layer, it is core framework layer. So here it defines the framework for graphics and media. It includes technologies like QuickTime and OpenGL. So the main framework for graphics and media, it comes under core framework layer. And the last bottommost layer, it is kernel environment. So in Mac OS and iOS, we call the kernel as Darwin. So the foundation of system consisting of the Mac microkernel and BSD Unix kernel. So here there are two types. One is Mac microkernel and BSD Unix kernel. Two types of kernel. One is Mac and another one is BSD. Applications can sometimes bypass higher layers to communicate directly with this environment.